Hello there, this is Billy. Last week we've created the Friedgemon that measures the temperature and humidity of your refrigerator. Today we are going to explain how the program works. So last week we've copied the source file into the /document/Arduino/Friedgemon folder. And inside the folder we have two files. First one with an ending of .ino, that one is the main source code. It will be compiled and then it will plot in other files as required through the #include statement. For example, this credentials.x file that represents all the ID and passwords. So let's open up the main source file first. So this is our main source file. Usually we'll start with the commands, like we talked about last time. /* begins the command, and then */ ends the command. So whatever inside will be ignored by the compiler. Okay, our first effective statement starts here. We include a number of libraries: the ESP8266 Wi-Fi, the Wi-Fi library, the PubSubClient.h, which is the MQTT library. These .h files are the variable declarations of those libraries. The actual code will be brought in when the compilation happens. And then we have included other files for the sensor, SHD20, temperature and humidity sensor, and some math function for calculation. Here we have defined the measurement interval. So here we'll measure a reading every 5 seconds. Every 5 seconds we'll send a command to the sensor to get the latest reading. We don't want to do it too often because that will burn the sensor. And then we will only publish the values if they changed. If there's no change for a maximum of 10 minutes, which is this NC measurement interval, then we'll still publish a value anyway. So we know that the sensor is working. This is the declaration of the object for the sensor. So we create an instance of this object for the sensor. Here is some variable to store the values of the sensor, both humidity and temperature. Now we include all the ID and passwords in the credentials.x file. Let's look at that file. So this file has your Wi-Fi SSID at home, your password for the Wi-Fi, and these two lines is important. We copy in the Adafruits.io user ID and the AIO key. Then we have the feed names for the temperature and humidity, and then the server name and the port number. Next, let's go back to the main source code. Here we have the string values for the temperature and humidity, and we create an instance of our Wi-Fi client, and using that we create an instance for our MQTT client, the PubSubClient. This program will also use the time.h to go to the internet NTP server to look at the current time. So we use this NTP server that represents Hong Kong, hk.pu.ntp.org. It's a global time server for everyone, but depending on your distance, it may be a bit slow. So if you can find your own time server in your city, go to ntg.org and find it. Otherwise, you can use pu.ntp.org. We need to set the GMT offset. Hong Kong is 8 hours ahead of the GMT, so we put in 8 times 3600 seconds. And then we have the daylight savings offset. Then we have a timer for the display time, because we don't want to display too often. So we will display the new value every second, or new time every second. So we have set this value to 1000 milliseconds. Next is the OLED display library, where we display our values for the temperature and humidity. So we need to include these two libraries. SSD 1306 wire is the communication protocol for the display. And then OLED display UI is the actual command for writing stuff onto the OLED display. And now OLED needs two pins, right? Which is the I2C connection for SDA and SCL. Last time we said it's D1 and D2. So SCL will be D1 and SDA will be D2. And then we'll create an instance for the OLED, and we name this instance display. And we're using the D1 and D2 again. D2 is SDA, D1 is SCL. And the 0x3C is the address, the I2C address of the display. Okay, and then using this display object, we create an instance for the UI for the OLED software. Okay, here is a program to scan the I2C bus to find any I2C device connected. So I won't go through that, this is a bit complex. Then the next function is called reconnect MQTT. So a function starts with a type variable, what type of value this function returns. If it has nothing to return, then we'll put in void, VOID. For this case, it has a boolean to return. That means it has a logic true or false value to return. True if the reconnection is successful, false if the reconnection is not successful. And this MQTT function has no parameters, so that's why we have a bracket, empty bracket. First, we use the command to check whether the client is connected. That means whether the MQTT server has been connected. If it is not connected, the exclamation mark means not. If it's not connected, then we will start putting our debug message that we are going to reconnect. And then we'll use this function to try to connect to the MQTT server. So again, we have the IO username, that is our login ID to adafruit.io, and our IO key, that is our AIO key, that we copy from our account in MQTT server of the adafruit.io. And then we print out some debug messages for the account we are using. And if successful, we return true. Otherwise, we say, okay, it's not successful. What is the error code? We print out some debug message and return false. Next is the setup function. As we discussed last time, the setup function will be run once when the ESP8266 boots up, and it will only be run once only. So what it does is to initialize the environment, make everything ready for the program to run. For example, we have the serial begin. We set up the port speed of the serial port so we can receive the debug messages through our serial monitor. And then we'll clean up the screen and print out some debug messages, which Wi-Fi SSID we are using. Next, we use the display object to initialize the OLED display. Then we clear the screen and flip the vertical screen because we have the pins upside down. So we flip the screen so you can see it properly. And then we have the text alignment. Align the text to the left. And we clear the screen again. We set the font of our characters. So we print out some messages to our LED display, including our program name, the author's name, and which Wi-Fi SSID you're using. And then we display it on the screen. Because all these lines, what they do is just put the thing you are going to display into a buffer, a memory in the program. But it will not actually write to the OLED to display it. This last command does the actual writing of the data to the OLED display. So remember, every time you finish preparing for the display, putting the text into the buffer, you need to call up display.display to actually write it out, display it out to the screen. So next we will use the Wi-Fi.begin to start connecting to the Wi-Fi using our SSID and password. And then we check the status, whether it's already connected. If it's not connected, exclamation mark equal means not equal to. If it's not equal to connected, then we'll retry after 0.1 seconds, 0.1 second, and we print a dot to say we are retrying. So this loop will go on until we are connected. So if you are not connected, you will just hang there and keep printing the dots. That means you have either the SSID or the password in the wrong place, or your Wi-Fi is located too far away and you can't receive the signal. And then we collect the IP address. So this Wi-Fi.local IP function will return the IP address. And this subfunction to string will convert that from the IP address format to a string format, so we can use it to display. So we are now going to display all these Wi-Fi value again. This time we display the S1, which is the IP address. And remember, we need to use the display.display to actually output the display. Send it out to the function is embedded in the stored it into a string. A string is just a number of characters together, ended by 0. And then we use this function to character array to convert the string value into a character. Because the MQTT library only accepts character as a parameter, it can't accept string. So we need to do the conversion here. We convert 6 digits, including the decimal place, to the character. And now we finally can publish our values. So we use our I/O username, the login ID for Adafruit.io, the feed name which is constructed, and here we use the client.publish function to publish our values. First we publish the humidity, so we construct the name of our feed using these 3 variables. Our username for login to Adafruit.io, /feed/ followed by the MQTT humidity feed's name. So you can double verify here. The MQTT humidity feed's name is humid1. Our I/O username is whatever we copied from Adafruit.io. So once constructed, we can put in the variable for value string. That is the value of the character array that we created based on the humidity value. We did a number of conversions to arrive at this character string. Okay, after publishing, we'll print a debug message that we have published. And then we set display now to true because now we have a new value to display onto our OLED. Next, we repeat the same thing, but this time we read the temperature using the SHT20 object. Again, we check whether the temperature has changed from the last time we measured it and whether it's already 10 minutes. If so, we publish it. We get the temperature value, convert it into a string for the first time, and then for the second time we convert it into a character array. And then we construct our feed name using user name /feed/ and the temperature's feed name. So again, temperature feed name is defined here. It's called temp1. And then we upload the value string, which is the temperature in character array form. And then we print out the debug message. We set our flag to display now. And then we reset the value of the last measurement time. Okay, after all this, we check the display now flag whether we need to display or not. If so, we clear the display. And then we print out what username we're using on Adafruit.io. And then we convert our datetime to a format that we can display, which is our usual mm/dd/yy and a blank, and the HHMMSS. So this syntax in sprintf is to convert a value to a displayable format and put it in a string. So it's similar to the serial.print, but it's converting and outputting to a variable that is a string. And this syntax means %02 means I will need 2 space, and then D means this is a decimal number. So I will need to reserve 2 places for a decimal number, and then followed by slash, and then again reserve 2 space for the decimal number, followed by slash, 2 decimal number, and then followed by blank. This is the year and day and time, year, month, and day. And then I put a blank followed by %02D. Again, reserve 2 space for a decimal number for the hour, followed by colon, and then the minute, followed by colon, and then the second. Comma. Comma means we will put in the variable to substitute into this space where we say %02D. So we use the time now variable, which is a structure and it's a pointer to the time. So we have the time year minus 100 because we only need to display the years within the century. We will skip the century number. The way the time value reads is it will start counting from year 1000. So 1900 or 2000. So the way this year start counting is 1901 means year 1. We are now in 2019, so we minus 100 and give 19, which is the year. And then the month, it start counting from 0, so we need to add 1. The day is the same. Day 1 of the month is day 1. So we don't need to adjust. And then we have the hour, minutes, and second. All this we don't need to adjust. Just to repeat, we need to adjust the year by minus 100 because year 1 is 1901. We need to adjust by adding 1 to the month because January is represented by 0. For the rest, we can keep it as is. No need to adjust. And then we'll display the daytime. Okay, and then we display the other sensor values, the humidity, followed by the percentage, followed by the temperature, followed by C for Celsius. So you see that this display string has a number here. This is the X cursor, this is the Y cursor. That means this is the horizontal value. So 0 means the beginning of the line, and 16 means line number 16 counting from the top. And the last one means line number 48 counting from the top, and also almost at the middle of the display. Each display has 128 pixels, so this start the displaying on pixel number 70, which is around the middle of the screen, and display at pixel number 48 counting from the top. Again, this line finally outputs the actual text to the display. The last line of the program is a client.loop. This is important for the MQTT library PubSubClient to work. You must have this line at the very end, so you can process any MQTT messages received. If you don't have this word, you will not be able to receive anything from the Adafruit.io server. You will only be able to publish but not receive anything. So even though in this project we are not subscribing to any feeds, so we are not receiving anything. Still, there may be other type of communication messages or command messages from the MQTT server, then you need to receive. So that's it. That's all the program. I hope you understand it. Next time we're going to work on the other project, which is the greenhouse. See you next time. Remember to subscribe and send to your friends to subscribe too.